Chapter 5.1, exercises, in this case 1 through 8. These exercises have to do with using trigonometric identities, and in this set of exercises we're going to use reciprocal identities, and those are the sine theta, and if you recall, sine theta is opposite over hypotenuse. Sine theta is going to be equal to 1 over cosecant theta. And likewise, cosecant theta is going to be equal to the reciprocal of sine theta, or 1 over sine theta. And cosine theta is equal to 1 over secant theta, and secant theta is equal to 1 over cosine theta. And then tangent theta is equal to 1 over cotangent theta, and cotangent theta is equal to 1 over tangent theta. So these are the identities we're going to use to solve, I think, all of these problems here in this set. Here we have cotangent theta equals 5/7. Find tangent theta. Well, we use our last identity we wrote down here, or one last. Tangent theta is equal to 1 over cotangent theta. Okay, and so in this case, tangent theta is equal to 1 over cotangent theta, which is 5/7. And dividing by a fraction, in this case 5/7, is the same as multiplying by its reciprocal. If we take this 5/7 instead multiply by 7/5, 1 times 7/5, well, tangent theta is equal to 7/5. And you should be able to see that this is just the reciprocal of the cotangent that we're given. So let's go on to our next odd number problem, which is 3. If tangent theta is 1/5, find cotangent theta. Well, here, similar to this last one, we're going to use this time the cotangent identity. So cotangent alpha, in this case they're giving us alpha instead of theta, is equal to 1 over tangent alpha. All right, so cotangent alpha is equal to 1 over, what was our tangent? 1/5. And again, we're dividing by a fraction. It's the same as multiplying by its reciprocal, so we take this 1, and so we multiply by 5 over 1. So we cancel out everything. Cotangent alpha is going to be equal to 5. That's going to be our answer. It makes sense, because if you have tangent is opposite over adjacent, well, that's going to be 1/5. Well, adjacent over opposite is going to be the reciprocal of 1/5, which is 5. Again, reciprocal being what number do you have to multiply by another number to equal 1? Well, 5 times 1/5 equals 1. Next odd number problem, 5. If cosine x equals 1/6 and sine x equals square root of 35 over 6, find cotangent x. Well, again, we're going to go to our cotangent x. Now in this case, there's I didn't mention the quotient identities. Well, the cotangent of theta is equal to, instead of well, it's going to be adjacent over opposite, which equals cosine theta over sine theta. So in this case, we have cosine theta and sine theta. So in this case, we'll write cotangent x is equal to cosine x over sine x. So in this case, for this particular problem, cotangent x, and we find cosine x, which is 1/6, over sine theta, which is square root of 35 over 6. It looks like it's pretty complicated to do, but now we just use that same 7th grade skill that we were supposed to have learned back then. Well, dividing by a fraction is the same as multiplying by its reciprocal, so we're going to, instead of dividing by a square root of 35 over 6, we're going to multiply by 6 over square root of 35. Okay, and so what do we have here? 6 over 6 cancel. So what we have left here is 1 over square root of 35. Now, personally, I'm satisfied with this, but there's something called rationalizing the denominator, where we don't want to leave a square root in the denominator by itself. So if we multiply by square root of 35 over square root of 35, what we're doing is we're getting the square root out of the denominator. So multiplying the denominator across, square root of 35 times square root of 35 equals 35, and 1 times square root of 35 is square root of 35. And so our best rationalized answer is going to be cotangent x is equal to square root of 35 over 35. And so that's going to be our answer. Now again, as a matter of technicality, I'm going to box in red. This answer to me, let me box this in. This answer to me really should be okay as well, because it does meet the requirement of technically being correct, what I've boxed in here in red. Let's go on to our last odd number problem in this set. If cosecant alpha equals 7/3 and cotangent alpha equals 2 square root of 10 over 3, find secant alpha. Well, we're going to need to use different things here to solve this one. First of all, we should remember that our cotangent of theta is equal to cosine theta over sine theta. So that's an important identity here for us to get this. And also, cosine theta equals 1 over secant theta, and sine theta is also equal to one over cosecant theta. So let's go ahead and apply these here. And what we have is, I'm going to write the one that we're going to apply here, which is we're given this cotangent theta. So I'm just going to write this here, cotangent, I'll say cotangent alpha equals cosine alpha over sine alpha. Well, in this case, we're given what cotangent theta is, and that is that is 2 square root of 10 over 3 is equal to cosine. And that's going to be cosine is going to be what? 1 over secant alpha, or 1 over, let's say secant, yeah, secant alpha, that's right. And then we're going to go ahead and write down it's over sine theta, right? So sine theta is 1 over cosecant theta, so that's going to be 1 over, and we're given cosecant theta being 7/3. And so really working this out, what we're going to have is we're going to multiply this, so we have 1 over secant theta times, now we have 1 divided by 7/3, and so what this is going to become is 1, this becomes, what that's going to become is 1 over secant alpha times 1 times 3/7, right? Because we're dividing this 1 by 7/3, multiplied by 3/7, and that's going to be equal to 1 over secant theta, or secant alpha, and then that's going to be times the reciprocal of that, which is going to be times 7 over 3. So that's what that is going to be. And so we have 2 square root of 10 over 3 is equal to 7 over 3 secant alpha. Okay, so what we can do is a number of things. We can simply, we're trying to solve for something in the denominator here, so we can just flip these fractions upside down. So this 2 square root of 10 over 3 can be 3 over 2 square root of 10 equals 3 secant alpha over 7. And 7 divided by, and we can divide both sides by 3, so we can cancel out these 3's. And what we can do is multiply by 7. So if we kind of cross multiply that 7, we're going to have secant alpha is equal to 7 over 2 square root of 10. And then this would be a sufficient answer. But if we go ahead and we rationalize the denominator, secant alpha equals 7 over 2 square root of 10 times square root of 10 over square root of 10, we get 7 square root of 10 over 2. Now, square root of 10 times square root of 10 is 10. So we're going to end up with 7 square root of 10 over 20. And so that's going to be our answer. Now, again, really, An unrationalized answer to me is also a pretty good answer. So anyway, that's the set of odd numbered problems. Good luck. This last one, number 7, took some doing, took some manipulation to solve for our unknown ratio. But other than that, really it's pretty straightforward using the reciprocal identities and the quotient identities, cotangent, tangent. Good luck. Thanks for viewing.